Okay, welcome back. We are today going to finish up our notes on graphing the quadratic equations in standard form. So yesterday we left off with number 3, and we're going to pick up with numbers 4, 5, and 6 today. And then we'll go back and do that practice page. Okay, so looking at this, just as a quick little refresher, the standard form is when it's in ax squared plus bx plus c. So remember, the a is always the number in front of the x squared. So in this case, that would be -2. The b is always the number in front of the x, but there is no single x here, which means the b is the 0, and c is always your constant, that number adding or subtracting to the end without any variable attached to it, and that would be -5 in this case. So just be careful, because sometimes when one of the terms is missing, people automatically think it's a C, or they mix up which one it is. So just be very careful about identifying your A, B, and C. Now the rest, we're just going to follow the same steps we were doing yesterday. So the x coordinate for the vertex and also the axis of symmetry is going to be found by doing -b over 2a. Now whenever your b is 0, you don't really have to worry about the negative sign, and then we have 2 times -2. Now, it doesn't really matter what you get on the bottom because 0 divided by anything is 0. So that means our axis of symmetry is x equals 0, and the vertex is also going to start out with a 0. So then we're just going to plug into the original equation over here, a 0 where the x's are. So we'll have y equals -2, 0 squared minus 5. Now, whenever you're plugging in a 0, that whole term is basically going to cancel out because it's going to turn to 0. So you end up with just y equals that c value, which in this case is -5. So the vertex is 0, -5. So now, once you're done with that, you're going to take that vertex point, 0, -5. We're going to plot the axis of symmetry, which happens to be the y-axis because it's x equals 0. And then we're going to use the graphing pattern, which is -2 times 1, 3, and 5. So -2, -6, and -10. So because they're negative, we're going to go down from the vertex. So down 2 over 1, and then we'll go down 1, 2, 3, 4, 5, 6 is a teeny bit off the graph there. Then you're going to do the same thing on the other side of that axis of symmetry, and then you're going to plot that parabola. So we can see that our vertex here was a maximum, and don't forget your domain is always all real numbers, and your range, all the y values here were less than that -5. Okay, so going on to number 5. So here my a value is 1/3. My b is the number in the sign in front of that x, so that's -2. And the c is 3. So finding that x coordinate, we're going to do -2, and then 2 times 1/3 on the bottom. Now, of course, double negative makes that a positive. So now we have 2 divided by 2/3. Now, 2 divided by 2/3 is really multiplied by 3/2, which equals 3. So x equals 3 is our axis of symmetry, and the 3 will also be the first part of our vertex. So to find the second part of our vertex, we're going to substitute in 3. So we have 1/3 times 3 squared minus 2 times 3 plus 3. Well, 3 squared is 9, and 9 times 1/3 is 3, minus 6 plus 3, and that's going to be 0. So our vertex here is 3, 0. So I'm going to go over 3 up 0. That's my vertex. My axis of symmetry is this vertical line going right through there. And then I'm going to use my 1/3 to do my graphing pattern. So I'm going to get 1/3, 3/3, and 5/3. Now, it might be a little bit easier to put these in decimal forms, so when you graph it, it makes a little more sense. So 1/3 is 0.33, 3/3 is just 1, and 5/3 is 1.6667, whatever. So we're going to go up 1/3 of a box. So up 1/3 and over 1. So I'm going to estimate where that is. Then from that point, I'm going to go up 1 box and over 1. And then I'm going to go up 1 2/3 boxes over 1. Same thing on the other side of the axis of symmetry. And this is going to be my parabola. And notice that because that a value was smaller, the graph is wider. Again, the domain, always all real numbers for these graphs. The range is the y value is going to be greater than, since we have a positive a, greater than, greater than 0. It's greater than this, whatever your y is on the vertex. Okay, so let's go through one more with all of those steps, and then we'll do a couple that are condensed a little bit. Okay, so this last one here, we have the a value, which is positive 1, the b value, which is 10, and the c, which is 25. So negative 10 over 2 times 1, so negative 10 over 2 equals negative 5. So the axis of symmetry is x equals negative 5. Negative 5 is also the first part of the vertex. So to find the y, we're going to substitute in that negative 5, and you can certainly do that on your calculator. Negative 5 squared is 25. Then we have minus 50 plus 25. So again, we get y equals 0. So negative 5, 0. My axis of symmetry is this vertical line here going through that negative 5. That's x equals negative 5. And then we're going to use the graphing pattern, which is 1 times 1, 3, 5. So 1, 3, and 5. Up 1 over 1, up 1, 2, 3 over 1, and then up 1, 2, 3, 4, 5 over 1. And then there is your parabola. Now, of course, this time the vertex was a minimum. The domain, all real numbers, and the range, the y values are greater than the 0 from our vertex. Okay, so because we had skipped that one page, I'm going to go back now to the page I had skipped. So if you printed this out, you could just put the papers in the proper order. And we have a few more practice problems here. So practicing this is the only way to get it. And then we have a few where there's missing numbers. So those are good to kind of make sure we touch base with those. Okay, so for number 1 here, we have A, which is the 2. Now you don't see anything else, which means both B and C are 0. So when I go to find my x, it's negative b, which is 0, over 2 times a. But remember, 0 divided by anything is 0. So that axis of symmetry is 0, and my vertex is going to start out with a 0. Now, if you plug a 0 in here, 0 squared is 0, 0 times 2, you're going to get another 0. So your vertex is actually the origin. And then that makes your y-axis the axis of symmetry. So now when you do your graphing pattern, 2 times 1, 3, 5, you're going to get 2, 6, and 10. So up 2 over 1, up 6 over 1, and then we can't fit any more. So then I'll do the others on the other side of the axis of symmetry. And draw my graph. The domain, of course, all real numbers. The range, y is greater than 0. Okay, so let's take a look at number 2. Again, A is positive 1, B is positive 2, C is positive 1. So we're going to go ahead and find our x, negative 2 over 2 times 1. So negative 2 over 2. So x equals negative 1. And now we're going to plug that in here. So negative 1 squared plus 2 times negative 1 plus 1. We get 1 minus 2 plus 1, which is 0. So negative 1, 0 is my vertex. My axis of symmetry is that vertical line, x equals negative 1. And then I'm going to do 1 times 1, 3, 5 as my graphing pattern to get a couple more points, which will just be 1, 3, and 5. So up 1 over 1, up 3 over 1, up 5 over 1, and then match them up on the other side of the axis of symmetry. And there's our parabola. It is a minimum vertex. The domain, all real numbers, and the range, y's, are all greater than 0 since it's opening up. Okay, so then the next one. Okay, so this one again is one of those very simplistic ones. The A is -4, however, the B and the C are both 0. So when you get one like that, you should love it because it makes everything easier because your origin or your vertex, automatically is going to be 0, 0. And if you don't believe me and you plug it in, right, x equals -0 over 2 times -4, 0 divided by anything is 0. And then when you plug a 0 back in here, you're going to get 0 for y as well. So as soon as you get a B and C that are both 0, you know your vertex is the origin. And you can just go ahead and write that. The axis of symmetry will also be the y-axis. So right away, we can start graphing this one at the origin. The axis of symmetry is the y-axis itself. And then we just use our graphing pattern. This would be -4 times 1, 3, and 5, which is -4, -12, -20. So from that point down 4 over 1, and then if I could fit 12, I would, but I'm not quite going to make it, so I'm just going to do those points I can fit. Of course, our vertex is a maximum this time since the A was negative. The domain is all real numbers as it is every single time. And then the range will be y is less than, since the graph's going down, that 0 value from the vertex. Okay, number 4. A is -1, B is -2, and C is 3. To find my x, I'm doing -b over 2 times A. That's going to give me 2 over -2, which gives me an x value of -1. Now, when I plug that in here, I have -1 squared minus 2 times -1. This is where sometimes people make mistakes because they put it in their calculator and they don't put the parentheses around that -1. So what's going to happen here is this -1, when you square it, becomes positive, but then it becomes negative again from the one on the outside. Then this will become a +2, and that'll become a +3. So you actually end up with -1 and +4 as your vertex. So -1 and +4, the axis of symmetry. And then your graphing pattern this time is -1 times 1, 3, 5. So that's going to make us go down to plot the points. So down 1 over 1, down 3 over 1, and down 5 over 1. Same thing on the other side of the axis of symmetry. Then we can see our vertex is a maximum. The domain, always all real numbers for these, and the range y will be less than the y value of the vertex, which is 4. Okay, so I've got 2 more to go through with you for a little extra practice. Now take a look at number 5. Now on number 5, we're missing a term. Which term is it? Well, we have the a, that's the number in front of the x squared, and it's -1. But the b is missing, so the b is 0, and then the c would be that -4. So when we go to find our x, -b, which is 0, over 2 times -1, will just work out to 0. Now, x equals 0, that's the axis of symmetry. The vertex will be 0, comma something. However, it's not a 0 because there is a c value. So the -x squared turns to 0 when you plug in the 0 for x, but then you have to subtract 4, so the vertex will actually be 0, -4. So we're going to plot that. The axis of symmetry is that y-axis itself. The graphing pattern is going to be -1 times 1, 3, and 5. So down 1 over 1, down 3 over 1, and down 1, 2, 3, 4. It's like one box off the bottom there. Same thing on the other side. Draw my parabola through those points. I see my vertex is a maximum. The domain is all real numbers, and the range is y is less than -4. All right, and then we've got one left to do together here. So my A is +1, my B is +6, and C is +5. To find that x, I'm going to do -b over 2 times A. So -6 over 2 gives me an x value of -3. So that would be my axis of symmetry. Now my vertex, I'm going to plug in -3 in parentheses for these x values up here. So -3 squared is 9. 6 times -3 is -18. Then we have +5. So -9 plus 5 gives me -4. So -3, -4. My axis of symmetry is x equals -3. And then my graphing pattern is just 1 times 1, 3, 5. So up 1 over 1, up 3 over 1, up 5 over 1. Same thing on the other side of the axis of symmetry. And there is our parabola. Again, it's a minimum. The domain is all real numbers, and the range is y is greater than, since it's opening up, that y value of -4. So hopefully that helps solidify what we had gone over in yesterday's lesson. I will save this answer key and add it to today's page, and I will give you some more practice to do, another practice homework on the quizzes. Enjoy the rest of your day. Thanks.